distance. Distance is the length of a segment between 2 points. And it's measured in general units. It's not measured in feet or inches or centimeters because we're talking about 2 points in space on a coordinate plane. And the distance between 1 and 2 is 1. Like, is the distance between numbers, but how big is that? I don't know, right? Like, it's the distance between 1 and 2. So we just call it 1 unit, like we just call it 1. So it's not measured in specific feet or inches or millimeters or anything like that. So if I have 2 random points in space, here and here, the distance is whatever length that is. Okay. The midpoint is exactly the same distance between the 2 points. It's the halfway point. So if we were talking about, let's say I had a point, let's do a different color. Okay. Let's say I have a point here, and this point is 4. Okay. And then I have a point over here, and this point is 9. Okay. The point that's exactly halfway between 4 and 9 will be the midpoint, right? So we'll have 5, 6, 7, and 8. I didn't draw that well. Let's make that 10.
No, but you did have a problem with that though.
I'll show you how to work that out. Just for the picture, I don't want to make it more complicated than it has to be. Okay, so if I have 4 and 10, halfway between 5, 6, 7, 8, 9, 10. That would be 7. So 7 would be the midpoint. Does that make sense? So it's just the point that's exactly halfway between 2 points. And there's a formula for both of these so that you can calculate them, which we'll go over in a second. Now, a bisector is any point or line or plane that intersects at a midpoint, so it cuts something in half. Okay, and I'm going to draw those on another page to show what it would look like, okay, because I don't have it in here. So if I have this line segment AB, okay, and C is a midpoint, okay. And another line comes down through here like this. This line will be the bisector.
And you see lines like that through the midpoint?
Yeah, you can see a line to the midpoint. It doesn't have to be straight up and down like this. It can go sideways as long as it intersects at that midpoint. It's a bisector. Yeah.
Okay.
A line, a bisector. This point C itself, because it's a midpoint, it's technically a bisector also because it cuts the AB in half. So maybe this would be like 2 inches, and this would be 2 inches, so they're the same size. It could be a plane, which would look like this if I had the line segment and then I had a plane cutting through it.
Is this one midpoint or
Both. So if you had a plane that cut through the line at that point, this would probably be dotted or something. It can be a ray, it can be an angle, but just basically anything that cuts something in half is a bisector. Better? Okay, so the distance formula on a number line different than the distance formula in a coordinate plane. Okay, so you can have the distance on a number line, which is one-dimensional, so a straight line, and then you have distance in a coordinate plane, which is two-dimensional, so you have things, you know, over, up in space, over here, and down here, and things like that. So number line, straight line, we do the largest number minus the smallest. Or you can do the number on the right minus the number on the left. Okay, because whatever's on the right is going to be larger than whatever's on the left. So that's how number line works. Anytime you're going that way, you're bigger than if you're going this way. So if we want to find the length of BE, that one's blue. Here's B. Here's E. E is larger than B. So E is 2. B is -6. And I have a trick that I use. Those of you that have had me before have seen this, but those that haven't. To remember what to do with this. Minus negative. Doesn't he look happy? And happy is positive. 2 plus 6.
So anytime I get a negative and positive.
Yep.
There's a negative and a positive.
Then you subtract the numbers. Okay, so if it was just 2 minus 6. Think about it like money. Okay? When you have a negative and a positive together, positive is money you have, negative is money you owe. So if I have 2 and I owe 6, how much do I still owe? You have 2, you owed 6, so you pay the 2. I still owe 4.
Okay, so that's
But if I owed 2 and I had 6, I pay the 2 that I owed and I have 4 left over.
So anytime a positive is a negative,
You subtract the numbers, and whichever number is bigger,
this side
you keep the sign. Okay? But if you think about like money you owe versus money you have, if you pay what you owe out of what you had, do you have money left or do you still owe more? Does that help?
Yeah. I'll erase that.
I won't. Let me do Okay, AC. A and C are here and here. C is -4, A is -7. C is bigger because it's on the right. So I'll do -4 minus -7. So happy. So I have -4 plus 7. So this is like we were just saying, if you owe 4 but you have 7, you pay the 4 and you have 3 left over. So +3 is the distance between those. Now you don't have to do this mathematically. You can count spaces on a number line. You won't be able to count spaces necessarily in a coordinate plane. If they don't line up in a straight line, if you have a diagonal, you can't count spaces. But if we wanted to find the distance between C and F, but we didn't want to do the math, I want to go from C to F, so I'll say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted how many spaces it was. Yeah, so I have 9 spaces, so the distance is 9. Now it works on a number line, but like I said, that won't work in the coordinate plane. Yes?
So why for the first one, BE, did you put the positive number?
Always the largest minus the smallest.
Okay.
So whatever one's on the right minus whichever one's on the left.
Okay.
So you kind of like write it backwards from how it appears on here. If I wanted to do this mathematically, it would be 5 minus -4. And since that's a positive, it's even there. So you can either count the spaces or you can just use the the math.
Okay.
So why don't you guys do FB? I'll erase all this stuff and get it out of your way so you can
Everybody
see.
can put the green eye on the screen.
Yes, I can. Hold on one second. The distance formula in the coordinate plane requires square roots because, here's why. I'm gonna just show you real quick. Okay, so I'm in the coordinate plane, and I have a point here, and I have a point here, and I wanna find the distance between them. Okay. If I draw this, I make a right triangle. And if I have a right triangle, I have the Pythagorean theorem. You guys remember the Pythagorean theorem? A squared plus b squared equals c squared. Every right triangle works like this. If I square this side, and I square this side, and I add them together, it equals this side squared. This is where the distance formula comes from, because the length of c, if I were to rewrite this way, and I take the square root of them, this is where the distance formula comes from. Now, this is not the distance formula. I'm just telling you where it comes from. So you know that it exists and that it's true, and I'm not lying to you. It comes from the triangle that you can draw between the points.
So we won't have to do what you just did.
No.
Not even on that test?
No, this is what you're going to have to do.
Cause that's easy though. A squared plus b. That's not like the distance formula is not easy. Yeah, this is where I fit.
You didn't have me.
I haven't took it yet.
That's true, so.
All right. It's actually the exact same thing, because the distance of A is the two x's minus each other, and the distance of B is the two y's minus each other. So it's exactly the same, it just looks different. So here's what we do, okay, guys? You need this formula, all right? And then we use the order of operations. Do you guys remember order of operations? What comes first? Parentheses. So we have to do what's in the parentheses first. Then we do the exponents, so we square them. Then we add those things together. And then you plug it in the calculator and you take the square root of it. And you have the distance. It's a lot of steps.
That's what messes me up.
So here's what we do first. We decide which one of these is x1. The second one? First one? It doesn't matter. You get the same answer either way. I usually just go ones, twos in order because I'm lazy and that doesn't require much thinking. But we can do it however you want. We'll do x1, y1. x2, y2, because every ordered pair is xy. And this 1 and 2 just mean the first x and the second x. That's all those mean. They don't mean anything else other than to tell you that this x is different than that x right there. They're just two different x's. So you could, in theory, have an x3, x4, x5, x6, and it would just tell you that they're just different points. Okay? You don't have to do anything with that other than to label these. Okay. The biggest thing that I see happen is that instead of subtracting the two x's, somebody will do an x minus y or a y minus x inside the parentheses. Or they'll say this is x1, x2, y1, y2. So just be really sure that each set of parentheses is an xy, xy. And it doesn't matter which ones are ones or which ones are two, but these both have to be ones. You can't do x1, y2. It has to both be ones and both be twos. Once you've got that down, then we rewrite the formula. Okay. Where you see an x1, we put a -4. Where I see an x2, I put a 5. Y1 gets a -6. Y2 gets a -1. Now you'll notice here I have minus -1 because there's that minus and then the minus from the -1. So there's 2 of them. So that has to be in there. He's happy.
What's that on the end? Is that parentheses?
It's a parenthesis around the -1 and then another parenthesis. So this parenthesis is for the -1s and this parenthesis is this parenthesis.
I always got confused because I thought you had to do something with the negative one.
You just minus the -1, which makes it positive.
D would be the answer, which would be the distance.
Yeah, D is the distance. Now,
Could just be A for answer.
because D for distance.
So it's not to make it a -1, it's just a +1.
Yeah, because it's minus minus, which is positive. So here I have -4, -5. 2 negatives.
So we,
That negative and negative, so I owe 4 and I borrow 5 more. So it's going to be -9. Okay, because they're both negative, so I add them together and I keep the negative. Here I have -6 plus 1. So I owe 6, I have 1, so I pay it, and then how much do I still owe? So that's going to be -5 squared. Now when I square a negative number, it becomes positive, because -9 times -9 is positive 81. 9 squared, -9 squared. And then when I square that -5, I'm going to get a positive 25. Now, on the distance formula, once you start squaring, these two numbers will never be negative. Because you're squaring something inside the parentheses. So if you get to this part and either of these are negative, there's a mistake. They need to be positive, so just double check your work, okay? So these will always be positive on this stage here. 81 and 25 is 106. 106 is not a perfect square, so I have not memorized the square root of it. So I'm going to put in my calculator the square root of 106. And I'm going to get some really long string of decimals because it is an irrational number because it's not a perfect square, and so it's a decimal that will never end and never repeat, and I cannot write all of those down. So we'll just use 2 of them. I get 10.295. The 5 rounds the 9 up to a 10, which rounds the 2 up to a 3. So I'm just going to write it up here, 10.3. Okay, so once I take the square root, it's going to be 10.3.
on the square root of 106.
Yeah, I wrote the equal wrong too, so that should be here. Okay. Yes. Okay, so x1 is -5. x2 is 8, so I have -5 minus 8 squared plus y1, which is 6. y2 is -4. Happy?
It's always X first, then Y.
Yeah, you subtract the x's, subtract the y's.
But I know, but like 5 is always X and 6 is always Y. The first number is always X, the second number is always Y.
Yes.
As far as when it's written.
Yes,
Before you
always
start
x, y. Anytime you have an ordered pair, we're using x's and y's because we're on a coordinate plane, but an ordered pair can actually be any letters. They will always be alphabetical. So if you're using A and B, it'll go A, B. If you're using P and Q, it'll go P and then Q. If you're using A and Z, it would be A, Z. It'll always be alphabetical.
Somebody knew what the smiley face meant. I mean, I'm starting to click in,
Cause he's a minus and negative,
so it
it becomes a positive.
So everything.
So anytime you have that double negative like that, I just make it smiley because it looks like a little happy person, right? Doesn't it look like a little happy person? And then happy people are positive. So that's how you can remember to make it a plus.
I've never heard it that way, but it makes it.
No, that's because I
easier
make it
to-
up.
It makes it easier in math.
Yeah, it's my own invention. I came up with that one myself. Okay, I have a -5 and a -8, so they're both negative, so I add them together, and it's still negative, -13. Yeah, negative and negative, so they're both,
Now, looking at the numbers, positive up there by the F, but you're subtracting, so it's.
yeah. And then I have 6 minus -4, so that's 6 plus 4, so that's 10. Okay, so the 13 squared is 169, 10 squared is 100. So I get the square root of 269, which I don't think is perfect. Nope, it's not. And that's gonna be 16.401, so I'm just gonna call it 16.4.
Always round the answer?
Yeah, you're gonna have to, because, if you have a not perfect square, it's irrational, which means it goes on forever, so you have to round it.
So if the next number next to the 4 was a 5, you would make the 4 a 5
Uh-huh.
always?
Yeah. Yeah, if I,